here's the question: can you use a gherkin as a light bulb? Well, firstly, please don't try that at home. I don't think it's safe, let alone the fact it would work for any length of time. Yes, I've seen it. I've seen it on television. I've seen Stephen Fry show it on his programme, and indeed they put 240 volts across a gherkin and it seemed to glow. What can only have been happening there? Well, inside the gherkin you've got a lot of water. A gherkin is just a pickled cucumber, and cucumbers are known for being 98% water. Pickle it, you've got a lot of vinegar in there as well. A lot of moisture. All that was happening, it seems to me, that on the electrodes it was burning, but all that water around it was evaporating off. So that the flame was being contained. And so yes, it was glowing for a period of time, but it's not going to last. So can you use a gherkin as a light bulb? Well, it gives light, so I suppose you can say you can for a certain amount of time, but don't bother changing the light bulbs in your house. It won't work. Okay, that's one of them. Other options we've got. We were asked about why does a raisin dropped into a glass of champagne seem to rise to the surface and go down and bob up and down so merrily? How could that happen? Interesting question. Well, next time you pour a glass of champagne, just look at it before you drink it and watch where the bubbles are coming from. They're not coming just randomly inside the glass. They actually come from specific points on the edge of the glass, and you'll see a stream of bubbles going up on the glass. Oh, what's happening there? Well, on the side of the glass there will be an imperfection. There'll be a tiny little notch or a scratch or something like that, and that's sufficient for what we call a nucleation point. It's a point at which the tiny bubbles of carbon dioxide that are dissolved in the water, basically that's what champagne is, water with a bit of flavouring, that are dissolved in the water there, can come out of solution and form this stream of bubbles going up. Now think about, for a second, what does a raisin look like? It's a shriveled grape. And on all that surface, that very large surface area for its weight, you've got a lot of nucleation points. And at these points, bubbles will appear. And the bubbles will begin to lift as they form the raisin. And then as they get higher, the bubbles will get larger. And you might notice that in your champagne as well. As a stream of bubbles rise to the surface, the bubbles get bigger. As they get bigger, because there is less weight of champagne pushing them down, the bubbles are allowed to grow in size. As they grow in size, they grow in buoyancy, and so they lift our raisin up to the surface of the champagne, and eventually they get to the surface there. They're so buoyant they break off, or they get to the surface and they burst. And so our raisin drops. But as it drops, it's still got these nucleation points, it still gathers more bubbles of carbon dioxide. And so it goes up and down and up and down. And actually, as many as schoolboys discovered over the last few years, the sweet that contains most nucleation points and the drink that is prepared to give its carbon dioxide most readily are Mentos and Diet Coke. And go on YouTube and you'll see so many examples of people having a lot of fun by finding the nucleation points of Mentos when they drop them into Diet Coke. That, I think, was our second major question. Our third one, well, the third one, one of the other ones that we looked at were dealing with that great programme of the fart. How much electricity is there? How much energy is there in a fart, ladies and gentlemen? I suppose another thing that brings us back to schoolboys. What is a fart? You've got to start somewhere. What is a fart? A fart consists of a lot of air that you've just sucked in and has gone through your digestive system. It's got to come out somewhere. It could burp up, or it could go out the other side. That is mainly nitrogen and oxygen and won't burn. There's not much energy available in that. But there is some hydrogen, a little bit of methane in the human fart. That comes from the bacteria in your gut. Oh, and by the way, you don't need to top up your good bacteria with yogurt. Your body makes plenty of it. In fact, if you didn't poo quite a lot of it out, it would come out of your ears, I should think, within a couple of weeks. So you don't need to top it up. Don't worry about that. That's a hobby horse of mine. Anyway, the bacteria in your gut make a lot of hydrogen and a little bit of methane. These must be the flammable gases that are in there. Now, I calculated that if you fart about half a litre, which some people say you do, of fart gas a day, and of that, 20% was hydrogen. I doubt it's as much as that, but let's err on the generous side, shall we? And we say that that hydrogen is going to burn, and we collected it all, and we did that for 6 3/4 years, 6 years, 9 months. You would produce a couple of hundred joules. That's nothing more than it would take to run a light bulb for about 8 hours. And that's it. You're certainly not going to have as much energy in there as has been claimed, ladies and gentlemen, to have an atomic bomb. If that were the case, the North Koreans would find another way of threatening the world without having to go around building their own atomic bomb. No. I reckon in order for a human being to create enough fart gas to match the 52 terajoules. I mean, that's a colossal amount of energy. There is an atomic bomb. In order to create that amount of energy, you would have to collect all your farts every day and every fart in every day for 100 million years. Now, it's less than that. Less than 1 million years since human beings first came down from the Serengeti. So let's assume that 100 people, 100 humanoids, swung down from their trees onto the Serengeti, and there they had with them a vast supply of plastic bags, and they collected their farts, and they put their farts away, and they taught their children to do the same, and this went on for generation after generation after generation as humanity spread throughout the world. The direct descendants of those first 100 humanoids all collected their farts one at a time. By now, yes, we could have an atomic bomb. It's probably easier to go to British Nuclear Fuels and make your own. Okay.